On the 20th of July 1969, Apollo 11 landed on the moon. 600 million people around the world watched as Neil Armstrong took mankind's first steps onto the lunar surface. This moment captured the excitement of a generation and fulfilled President Kennedy's goal of landing a man on the moon by the end of the decade. But how did NASA broadcast live footage from the moon all the way to a record number of people back on Earth? In this video, we're going to look at the challenges involved in broadcasting live footage from the moon. We're also going to look at the technology that went into making it happen and how it was developed for future Apollo missions. In the early 60s, NASA began working on the rocket and spacecraft that would eventually take humans to the moon. At that time, America had only sent a handful of astronauts into space, and no human had ever left Earth's orbit. This ambitious plan to send humans to the moon was met with a lot of skepticism, and NASA knew that live video of the astronauts walking on the moon would be crucial for the mission's credibility. NASA contracted electronics company Westinghouse to design and manufacture a small black and white camera that would be capable of capturing man's first step on the moon. This camera would need to operate on a mere 7-watt power source and be able to survive the harsh radiation and extreme temperatures found on the moon's surface. Most importantly, the lunar module would need to be able to send live video feed all the way back to Earth, along with other radio and telemetry data that was already being sent back. NASA realized the Apollo missions would require a brand new communication system in order to send data back from the moon. They developed a system called Unified S-band, which would send telemetry, command, voice, and television data using different frequencies, but combined into a single antenna. However, even with this new system, there wasn't enough bandwidth available for a standard 525-line video camera. In order for the video feed to fit into the downlink, Westinghouse developed a slow scan camera, which transmitted 325 scan lines at a mere 10 frames per second. This camera would be connected to the lunar module via an electrical cable, allowing it to be moved around the landing site. The video would be transmitted from the lunar module's antenna back to a tracking station in Australia, where NASA would convert the image to a standard broadcast signal. That signal would then be transmitted up to a communication satellite and back down to Mission Control in Houston, where they would broadcast it to the rest of the world. However, the challenges of filming on the moon didn't stop there. The incredibly high contrast between the lunar surface and the darkness of space would make capturing a clear image on the moon extremely difficult. To solve this problem, Westinghouse used a piece of classified technology which they had developed for the Department of Defense. They had developed a special low-light imaging tube, which was used on jungle surveillance cameras during the Vietnam War. This could capture moving objects at low light levels without completely blurring the image. As the first manned Apollo missions loomed ever closer, the camera was ready, and it was on Apollo 9 where it would go through its first and only test. The camera was placed on the lunar module, and the mission successfully tested the camera along with the communication system. The camera's next task would be capturing man's first step onto the moon. 20th of July 1969. Apollo 11 touched down on the moon. With the camera placed on the side of the lunar module aiming toward the ladders, Buzz Aldrin hit a circuit breaker from inside the cabin to turn on the camera. At the start of the broadcast, the footage appeared to be upside down. Video operators in Australia who were handling the signal quickly inverted the image to fix the issue, just in time for Neil stepping onto the moon. There was a great deal of contrast in the image, and a lot of detail was lost through the conversion process. But the footage clearly captured one of the most historic moments in history. The camera performed its job perfectly throughout the mission, and remains on the moon to this day. Future Apollo missions used a more advanced version of the camera, which filmed in color and had better low-light performance. Apollo 15, 16, and 17 cameras were also placed onto the lunar rover. Once the astronauts were leaving the moon, they parked the rover at a distance, and a camera operator back at Mission Control would command the camera to tilt up, following the astronauts as they left the moon's surface. So although we have never been back to the moon, we can appreciate the effort that went into capturing these historic moments in a way that we will cherish forever. And when we do eventually return to the moon, the advanced camera technology that we have today will allow us to capture the moment with even more beauty. Thank you to the Primal Space patrons who helped to write and research each video. If you'd like to contribute to Primal Space and join our exclusive Discord, please visit patreon.com/primalspace, where we will be giving away another Saturn V Lego set once we reach 100 patrons. So make sure you're subscribed so you can join in the discussion as we continue to learn more about all things space. Thank you very much for watching, and I'll see you in the next video.